Mount Etna is known as one of the most active volcanoes in the world. Its eruptions often attract attention due to their extraordinary power and widespread impact. But beneath the visible activity on the surface lies another, much quieter phenomenon, something moving slowly, almost imperceptibly, yet holding the potential for significant long-term risks. This phenomenon is the movement of a large portion of Mount Etna slope slowly moving toward the Mediterranean Sea. This movement does not occur suddenly, but rather occurs very slowly over the years. Scientists estimate the rate to be around 10 to 15 millimeters per year. Although seemingly small, this shift is a significant geological signal. What makes this situation particularly striking is the scale of the affected area. It's not just a small section of the slope that's moving. A vast area on the southeastern side of the volcano is also shifting. This suggests that Etna isn't simply changing due to magma pressure from within the Earth. Other processes are at work slowly, creating a more complex dynamic than what's visible on the surface. Research indicates that the primary factor causing this movement is a combination of gravitational forces and the conditions of the subsoil beneath the volcano. Beneath Etna lies a relatively weak and unstable sedimentary layer. This makes the mountain's foundation insufficient to support the massive mass above it. As a result, the mountain slopes slowly slip toward the sea like a heavy object on a slippery surface. Scientists' concern grew after a crucial observation in 2017. At that time, the underwater part of Mount Etna slopes was detected shifting by approximately 4 centimeters in just 8 days. Surprisingly, this movement was not accompanied by significant earthquakes. This phenomenon is known as aseismic slippage, which is movement without perceptible vibrations. In recent years, further research has provided a deeper understanding of this mechanism. Scientists discovered that fluid pressure within the rock's pores accelerates the shift. When this pressure increases, friction between rock layers is significantly reduced, allowing the slope structure to move more easily under the influence of gravity. This continuous gravity-driven sliding raises a critical concern: the potential for a catastrophic slope failure. The phenomenon of sudden volcanic collapse is not new in Earth's history. One clear example is the partial collapse of Anak Krakatau in 2018, which triggered a devastating tsunami. Evidence of large collapses has also been found in the Canary Islands and Hawaii. All of this suggests that similar events have occurred on a much larger scale in the past, making the current monitoring of Etna all the more crucial. So, what might happen if a large portion of Mount Etna's slope collapses into the sea? In a very rare, extreme scenario, this event could potentially trigger a massive tsunami. The waves could reach significant heights near the source before spreading across the Mediterranean Sea. The impact would undoubtedly be felt by many coastal areas. Coastal areas in Italy, particularly around Sicily, would be the most vulnerable to the immediate impact. However, the effects would extend beyond that and could potentially reach North Africa and the Middle East. While this sounds alarming, scientists emphasize that this is not an imminent threat. The process is a long-term geological process. Currently, Mount Etna is a major focus of international geological research. Scientists utilize technologies such as GPS, underwater sensors, and computer modeling. All of these tools are used to monitor every tiny change. The goal is to understand the process more accurately and anticipate potential future risks. In essence, Mount Etna is not only active in terms of eruptions, but also in terms of slope movement. This slope movement may not be noticeable now, but its impact could be significant in the long term. This phenomenon serves as a reminder that major changes on Earth often occur slowly, and precisely because of this, they often escape human attention.